Good morning, everybody. Myself, Dr. M Nimbark, professor at Gnan Manjari University, located in Gujarat, India. Our topic is distinctive formal educational affirmation verification and authentication using improved, customized, and responsive solidity-based Ethereum blockchain technology. Always we know that when the digitization will come into the picture, the trustworthiness of the data or document that always a question mark in our mind that whether the data we are storing will get altered or not, or whether it will be altered, then who is the responsible for that? So that's why to solve this problem, we have chosen this topic and we have worked it out on that. I'll give you the overview about the work that we have worked it out using the blockchain and the capability of the blockchain through the smart contract, through the solidity related activities. We have also added some algorithms. Based on that, we could able to manage the data mining in efficient manner. We also use Web3 Ether libraries to communicate with the specialized tool like Flash server. Try to build the node in a private blockchain and try to store it properly, the data of the individual student, so that nobody can alter it, nobody can modify it, and whenever the data required, it should be in a original format or authenticated way. We could be able to provide the data of the educational affirmation of the individual students. Always we are thinking that somebody can alter my data, somebody can misuse the data, or somebody can modify data and misuse it. So that can be resolved using the blockchain, using the work that we have already done. I'll happy that based on this overview, my colleague Ms. Aneri will give you the detail about the work that we have worked it out from step by step, from blockchain to the contract deployment, wallet system simplification, and the Flash server tool that we have used to communicate with the nodes. We have some algorithms and library that we have used. Thank you.
Namaste, my name is Aniri Khodra and I am here to represent our research paper on a blockchain technology with a result management system. In today's world, information system is flawed in a many ways. That just being said, current system suffers from poor role hierarchy, vulnerabilities, bad QA test, and the most important flawed human social engineering. Not all the problems can be fixed, but we can fix most of them by upgrading our internet standard by using blockchain. Blockchain is not widely adopted because it's hard to make a tool which can interact with blockchain, but it's even harder to maintain it due to its rapidly developing nature. Blockchain technology is essential because it provides a secure, transparent, and decentralized way to verify and store information. Its immutable ledger ensures that data cannot be tampered with, which is crucial for maintaining trust and integrity. In a credential verification, blockchain eliminates the risk of fraud and streamlines of process, making it more efficient and reliable. This technology also fosters transparency and accountability, as all transactions are publicly accessible and verifiable. In our system, we integrated blockchain technology into result management system where we try to reduce risk of data breaches due to mismanaged roles of poor encryption, the bribery that takes places in many institutes in exchange for fake degree. The components of our system are as follows. The Web3 initialization and the get node connect facilitated interaction with the blockchain. The contract deployer streamlines the smart contract deployment and reuse. The simplified wallet system enhances the security by eliminating private key storage. The Flask server and data retrieval methods enables seamless user interaction with the blockchain, ensuring data accessibility and integrity. First of all, Web3 initialization and connection to Get node. In this one, the first step is to initialize Web3 and connect to the Get node server. This connection is like establishing direct line of communication with the blockchain. Once we are connected, we can create a smart contract object. Think of this object as a remote control that lets us interact with our specified contract. The contract deployer component simplifies a smart contract deployment by estimating gas, deploying the contract, and saving its address for the future use. The wallet system provides a secure decryption using a public key and a password, eliminating the need to store private keys. The Flask server handles various blockchain operations via HTTP POST request, allowing easy data retrieval and submission. Data from a smart contract is converted to JSON format for user-friendly interaction. Next is contract deploy component. In this one, the contract deploy component streamlines the process of deploying smart contracts and ensuring easy accessibility and reusability. It automates key steps including estimating the required gas, initiating the contract deployment, and waiting for the transaction receipt. Once the deployment is confirmed successful, it saves the deployed contract's address to the file for future reference. This simplifies contract management, making it straightforward to deploy and interact with the smart contracts on Ethereum blockchain. Now, third one is wallet system simplified. Now, let's talk about wallets. Our system makes managing user wallets simple and secure. Instead of storing private keys, which can be risky, we provide a method for decrypting user wallets using public key and password. This method enhances security and simplifies wallet management. Imagine it's like using a combination lock instead of carrying around a bunch of keys. Next is our Flask server. This server is like an engine of a car, handling everything from authentication to transaction storage. It provides easy to use endpoints for users to interact with our system. Think of it as a well organized highway system, making sure everyone gets to where they need to go efficiently. This handles authentication, validation, mining, and storage of transactions and smart contracts. It also provides endpoints for interaction via HTTP POST request. It also allows users to retrieve and submit data effortlessly. Finally, let's discuss data retrieval. We call the smart contracts function using to get our data. It's like calling a friend for information. Then we extract the data into variables and format it into a list of dictionaries. This process converts the data into JSON and making it easy to interact with and manipulate. We need a Web3 framework to create a secure, efficient, and a scalable blockchain application. Get provides a reliable execution environment for managing transactions and smart contracts, ensuring participation in the Ethereum network. Deploying and saving smart contracts addresses streamlined contract management, making it easier to reference and interact with them. Efficient mining allocation optimizes CPU usage, balancing energy consumption and mining performance, which is crucial for maintaining a sustainable and responsive blockchain system. Overall, this integration enhances usability and performance of blockchain application. First of all, combining Get, Python, Flask API, and Solidity smart contract. In this, it creates a powerful framework for interactive blockchain application in which Get manages transactions and smart contracts, while the Flask API handles authentication, validation, and interaction via HTTP requests. Solidity smart contracts provide the blockchain logic. This integration ensures efficient deployment, secure user wallet management, and optimized resource allocation of mining. Now, next one is the Go Ethereum server, which means Get or Go Ethereum is Go based implementation of Ethereum. It serves as an entry point to the decentralized web, being one of the earliest and most reliable implementation. This manages transactions, deploys and executes smart contracts, and incorporates the Ethereum virtual machine. This running get alongside a conscious client allows a computer to function as an Ethereum node, participating in a network operations. Now third one is deploying and saving smart contract address. In this, it involves several crucial steps. Equally as the deploying a new application, here's the process. Retrieve the contract object and bytecode and think of this as gathering all the necessary materials. Now next one is estimate gas. It's just like estimating fuel for a trip. Next is the initiate a deployment transaction. In this, it's like hitting the start button on your journey. Next, wait for transaction to be mined. In this, we wait for confirmation ensuring everything goes smoothly. Next is the retrieve contract address. In this, once confirmed, we get new address. Finally, we save this address to a file for future reference. In this process, streamlines the contract management, making it easier to reference and interact with them. Next is efficient mining allocation for lower energy throughput. In this part, mining can be resource intensive, so we need to manage it efficiently. Here is how we do it. Dynamic monitoring. In this, we continuously monitor our CPU usage, adjust them allocating when a CPU usage is below 10%, we assign 2 or fewer threads. For example, we check our CPU count. If CPU usage is below 20%, we assign 1/4 of the available threads. For every 10% increment in CPU usage, assign an additional thread. In this approach, optimize CPU consumption during a low usage period while ensuring sufficient resources during high demand scenarios. It reduces power consumption but increases transaction mining time during low CPU usage. Now, the crucial part of our blockchain application is the response times of our API endpoint and how we handle transaction backlogs. How many of you have experienced slow response times on a website or an app? Frustrating, right? Well, on an average of our endpoint respond within 1 millisecond to 3 milliseconds depending on a CPU. Not bad, but we have seen some failures due to backlog of transaction leading to the error transaction underpriced. This happens when the gas price for transaction is too low compared to others in a queue, causing delays. So what can we do about it? One straightforward fix is to implement a loop in the mining functions that keeps trying until the transaction goes through. Imagine hitting a refresh button on a web page until it loads. While this can work, it might significantly increase the response time as early retry adds to the overall waiting time. Now let's put this into perspective. Imagine we have an audience of 1000 users. For the most endpoints that just retrieves data stored in Solidity, these delays wouldn't be big deal. This endpoint is mainly for reading data, so it doesn't face the same challenges as which involves writing data. But let's consider a more intense scenario. What if 250 of those users who try to input a data simultaneously? That's like one request per second. While this situation is highly unlikely, it's important to recognize its potential impact on our transaction times and some system performance. By understanding these issues and addressing them, we can ensure our blockchain application remains efficient, reliable, and scalable. This means a smoother experience for our users and a more robust system overall. In the future possibilities, we can implement proof of authority, a newer type of consensus mechanism that is a better and efficient than proof of work, which is also currently immutable. Our research paper shows the power of blockchain in the education system, resolving one of the leading issues like mark alteration, fake degrees. I'm just stating few. The possibilities are endless, from implementing a full finance system to supply chain management. This only shows the mere power of blockchain that it can be bring to the IT world. as the graphics card being more powerful and consensus mechanism like a proof of authority, making a blockchain even more secure and efficient. The true power is yet to be unleashed when it's integrated in all parts of IT where it is needed. That's conclude our presentation. Thank you all for tuning in. It is a great honor and immense gratitude that we stand before you today. We are truly humbled to have given the opportunity to present our paper at this esteemed conference, which has brought together such a remarkable assembly of minds and talents. I would also like to extend my heartfelt congratulations to everyone.